Dear ladies and gentlemen, it's my great pleasure to welcome you again to our Energy Forum 2021, which this year is a YouTube channel and YouTube cluster. I'm your host, Robert Juodka, as usual, and the event is presented to you by the Estonian Chamber of Commerce in Lithuania, the Polish-Lithuanian Chamber of Commerce in Lithuania, and PRIMUS law firm, together with our partners, the Estonian Embassy, the Finnish Embassy, the Polish Embassy, and our main sponsor and provider of green energy in the Baltic region, Enefit Green. Today we are going to talk about the fallacies of hope, fallacies of hope in renewable energy. Well, for many years, at least 20 or 30 years, there have been a lot of discussions and a lot of talk and a lot of investment into renewable energies. But solar and wind are still only a very tiny fraction of the overall energy production. You know, despite all the investment, despite all the hype and all the PR effort, it is still about 10% of the overall energy production, and in different areas and different regions, it's even less. So what's the problem? Why is this happening? There are obviously many economic, social, political factors, and this will be the topic of our today's discussion here today, with a very renowned international expert, Mr. Vytautas Butrimas, from the NATO Energy Security Center for Excellence. Vytautas will tell us about his view and his institution's view about why this situation really exists. Why, despite all the investment and all the developments into renewables, solar in particular, we still continue to burn a lot of coal, a lot of natural gas. For example, the big green jump in Germany is actually at the moment de facto finishing of burning of coal and switching to burning of Russian gas, which is supposedly cleaner. Is it really the de facto and the big breakthrough in the energy sector? That is the big question we should ask ourselves, and what are the reasons behind. So without further ado, Vytautas, the floor is yours.
Okay, I'll share my screen. And I hope you can see my screen.
Yes.
And it's the full screen now?
Not yet.
Okay. Is it there yet, full screen?
Nope.
Let's
loading.
See what I need to do.
Press F5, I guess.
Let's see, I thought I was doing it the other time. Let's see. I'm screen sharing.
I mean, we see your slides, but they're just not full screen.
Okay, well, maybe because I don't see what I did the other time.
Now we have it full screen. Essentially, if you
okay.
press F5
okay.
once more. But F5.
F5. I apologize for the delay, but these it's still okay. Display setting. How about now? Full screen?
Yes.
Okay.
Yes.
I remember.
Finally, good. We're set.
Okay. Well, thank you very much, Robert, and congratulations on your mountain climbing exhibition, which I hear was challenging but very successful.
Thank you for that.
And before I make my presentation about climate change and renewable energy solutions, Fallacy of Hope, I want the people that are listening to me, I have some mixed feelings about this presentation, because I really want to buy an electric car. I really want to buy solar panels. I really want to put them, at our summer house where we have fields and get the electricity and, do all these things. But I have run into some disturbing facts, which I will try to present to you, and perhaps we can discuss and understand this issue a lot better. First, a few words about the NATO Energy Security Center of Excellence. We support NATO nations and partners to meet the challenges of a dynamic energy security environment by addressing resilience, energy efficiency, and critical energy infrastructure. And climate change is definitely a big issue, even in the defense sector, is how do you supply fuel to the soldiers in the field in harm's way? How can we be more efficient? And in our civilian societies, we're experiencing the climate change. So we're interested in this topic as well. We have exercises and we give courses. And in the center of this slide is a very important study we did. It's one of the first studies on the hidden cost of solar photovoltaic power. I did not write the article, but I encouraged the author, Mr. Thomas Trozak, to write it and to put it out. And we published it on our website. You can access it and read a copy for yourself or send me an email. We have a publication called Energy Highlights, and there you see one of the premier issues is about wind power from the cover. And so I think I'll establish some credentials for knowing something about renewable energy sources. Now, climate change and renewable energy solution questions. Now, think about this as I'm talking about these issues. Have we calculated the total costs versus the savings? The energy savings, you buy a solar panel, you save electricity, you don't burn fossil fuels, right? And the impact, there's also perhaps an environmental impact that I'll talk about. And can we address climate change without a change in lifestyle? Have we thought about that? Every day or every other day, I bring a bag of plastic and I take it to the yellow igloo down the street to try to recycle, to try to do something about the plastic. But I'm like the only one in my housing block that's doing that, so lifestyle change is an issue. And it seems sometimes that, like this picture, we're sort of following the lead of the green revolutionists saying, we have to do something about climate change. The technology will save us, the green revolution, the renewables, solar, biomass. You know what biomass is? It's trees. So this is what I'm going to talk about. Well, you see on the right side, this is a solar panel brochure. This is what many of us who are interested in buying solar panels to save energy and cut down on the fossil fuel use. This is what we get. Oh, really looks nice. Green, the sun is shining, the grass and is growing, the flowers, and we're saving electricity by having these panels on our roof. We're paying less. But then, look at the process that took place before you get the brochure, before you go into the store to buy, to talk to the salesman. Look what's happened. You had to mine high purity silicon. High purity means, silicon is the second most plentiful element in the world next to oxygen. Oxygen is number one. Silicon is the second in the Earth's crust. But, not all of the silicon is in a good form that you can use to make a pure form for a solar panel or for a computer chip. You have to have high purity. And to do that, you have to do a lot of mining, melting, smelting, transporting. You're burning coal, you're burning petroleum coke, you're burning wood chips, and you're mining quartz to get the pure silicon. Electric arc process, lots of megawatts of electricity. And, and the carbon reacts, and then you have emissions. Oh my gosh, what comes out of the manufacturing? Carbon monoxide, and look, sulfur dioxide, carbon dioxide, greenhouse gases. So this is, here are some facts. Smelting the silicon releases 5 to 6 tons of carbon dioxide per ton of silicon smelted. Think about that. Then to make this refined form before you make the solar panel itself, the plant itself consumes 1 to 6 tons of magnesium silicon and requires at least 175 megawatt hours of additional electricity per ton of polysilicon produced. So you see, this is what's behind the brochure. And you're buying the panel, you're thinking you're saving electricity, but on balance, maybe you haven't saved much on the carbon. Maybe you've added more carbon, who knows? But this is some of the things we have to think about and is discussed in more detail in this article that I mentioned. You know, what are windmills made of? And at what carbon dioxide cost? Well, fiberglass fiber, hybrid glass, carbon fiber, thermo, that means heating, thermoplastic, resins, heating again, electric, burning coal, burning natural gas to produce electricity, and making metal bolts to anchor these big windmills. And they're getting bigger and bigger. You know, the ones they're putting on the oceans, the offshore, they're huge. I'll show you some pictures. So you need lots of steel, lots of bolts, and the rotor, actually it's a wing that spins around. That has a lot of problems. You have to clean it. A lot of bugs, a lot of birds get killed by it, flying by it. And then to make the cement, the pedestal, I never cared much about cement. You know, cement is cement. We buy it and we use it, and you know, we construct our houses and roads and all that. But I found out that to manufacture 1 ton of cement releases approximately 1 ton of carbon dioxide into the atmosphere. Think about that. And the energy required to produce 1 ton of cement in the United States is about 1,500 kilowatt hours. You know, here's an interesting fact. Cement accounts for 83% of total energy use in the production of non-metallic minerals and 94% of carbon dioxide CO2 emissions. So, you know, energy represents 20 to 40% of the total cost of cement production. It's an amazing fact. You know, just to build the windmill, you think, well, the wind is going to spin and we make electricity and we're going to cut down on fossil fuel, we're going to reduce carbon. But what you've done to get to the point where you can start spinning the windmill is you've put a lot of carbon into the atmosphere. You know, and we talk about life cycle. You know, they're saying now, you know, the price of solar panels is going down. You know, the wind power is going down. It's going down all over the. You know, it's really, you know, and it is going down. But you know, they say here a typical wind turbine will pay itself back after 6 months, and the carbon dioxide that it uses will pay back after 6 months. But unfortunately, if you look at the process from the beginning, you know, the consumption of a 2 megawatt, that's like an average size windmill turbine, is equivalent to 3,295 megawatt hours. It's enough to power a single home for 375 years. So you see in the graphic on the bottom left, you move to the right and above, raw materials, the silicon, the carbon, the suppliers, the transportation. You're burning a lot of fuel to transport these raw materials and you know, to bring it to the customer, the manufacturing process, transporting, and then you can start saving money with the renewable energy. But then you have a problem. No one's thinking about the waste. You know, how do you dispose of these things? How do you dispose of a solar panel? It's got toxic substances on it, chromium, things like that. They're saying they'll send it to Africa where they'll take it apart and they'll melt it down. Well, it's a hazard. So these are, and the capital expenditure for constructing existing solar and wind totaled 2.3 trillion euros. Imagine to manufacture, to mine, manufacture, transport, construct. That's how much we're spending, and how much we think we are saving. Hard to figure out. You know, I don't have the complete answer, but I'm working on it. Don't forget to think about the maintenance. You know, I said they're building bigger and bigger, you know, wind farms, and out in the sea where there's more wind, they're making them really big. Look, you need a ship like that to maintain it. And if it's a windy day with lots of waves, you can't go on that platform. It's too dangerous. Then the wind wings break down. They have, you know, tears because they're, you know, resin epoxy. They spin around, you know, the edge, how fast the edge of that windmill is going. It's like 200 kilometers an hour. So that's a lot of stress. So maintaining it is a big deal. You have to send people up into harm's way. Some people have fallen from those platforms trying to maintain these systems. So maintaining renewable industry, just to maintain it, to make sure it's running as it should be. 13 billion a year industry is a figure that I've come up with, found. And now, can we, like the Germans did, they phased out their nuclear power plants. They're going to make their energy, electricity out of renewables, the sun, and they're going to stop the coal. They're going to sun and solar and wind. Well, can they fill the energy supply gap? Because people are still going to want to use their electricity. Last year in January in the state of Texas, it's like as big as a country in some parts of the world. It's a big state in the United States. They had a cold wave. They're used to warm weather in Texas. It's in the south of the US, but they had a big freezing -10, centigrade. And they had problems. About half the state's wind turbines froze and shut down because it was cold and they weren't winterized properly. They couldn't spin and they started to malfunction. And this happened to the natural gas pipes that were not winterized. The valves froze and the gas wouldn't go through. So you had people living for a week without heat and their pipes froze. And here you can see this graph. The yellow is from the solar at the top, and the orange is this big chunk that shrinks. Okay, so
it's
this
natural gas. I understand, according to your graph. The orange is natural gas. Essentially 80% of the energy. So you had this, and the natural gas also gives off what when you burn it? It's carbon dioxide. It goes. Okay, so can we reduce the energy demand? There's one little fact for you. Think of all the years that we've been hearing about solar panels and windmills. I mean, we go in Lithuania, we go towards the seaport of Klaipėda, we see these windmills showing up, and you fly to Denmark and Copenhagen, you can see the windmills in the sea near Sweden and so forth. So they've been around, for at least 10 years or so, at least, the sun and the wind. And it turns out that all the peak power that we get from the renewables, from the wind and the solar panels, all this time is 0.5 terawatts. All right, that sounds, peak power means it's when the wind is at its peak, when the sun is fully out, that's the peak power, 0.5 terawatts. But world electricity demand, how much the world demands? The renewable is giving 0.5 terawatts, 18 terawatts to meet the world demand. And we're not even thinking about what happens when the developing countries of Africa, we've seen Asia, China is big powerhouse. They're going to have big energy requirements, lots of electricity. African countries are coming next, South America. So that 18 terawatt, is there a way to stop that? Probably not. Because one of the things that I think is the toughest issue behind climate change, doing something about climate change and reducing carbon dioxide emissions so we don't go past the 1.5. I guess we've passed it. So Greenland ice doesn't melt completely and the sea doesn't rise 2 or 3 meters and the cities get flooded, is the lifestyle change. We need to do something where we don't have to have so much electricity, or the way we make the electricity has to be much more efficient than it is now. And the renewables, the way they're manufactured, has to be much more efficient than it is now. And some say the solution, but look at the picture here. This is what happens when a new product comes out. We're big consumers. The new Apple iPhone. This is the line that starts out the day before they actually start selling it. We have a consumer, consume, and electricity is the same thing. Especially during the COVID. I'm sure a lot of us kept a lot of lights on in the house because we were home during the quarantine. And now we have recovery from the COVID pandemic. We've basically reached the point of energy consumption that we did before the quarantine, and it's going up again. Historical surveys have many times indicated that actually invention or addition of new energy sources like solar or nuclear or wind or whatever, to the existing energy sources actually does not replace them, but comes in addition, comes on top of the existing energy resources. And the actual graph and actual consumption actually confirm it. So that solar never replaced anything; it just came on top, in addition to already existing.
What's happening? They're closing the coal plant, but they're finding they have to build 2 new natural gas turbine plants just to make sure there's a steady supply of electricity, because the sun and the wind are not always there at full force. So you have to meet the gap. Nobody wants to say, oh, in Vilnius for 3 hours today between 12 and 3, we're not going to have electricity because it's a cloudy day. The power has to be there. The hospitals has to warm the patients. People have to go to work and school. So this is what I think what we're seeing here. This is the real challenge. Can we do this? Technology can help us make it more efficient, more, maybe find ways to use that renewable, but still you have this gap of power that you're going to have to get from someplace. And if you're going to get rid of nuclear, we're not going to talk too much about nuclear today, but that seems to be, in the long run, if you want to have steady power and with the least amount of waste, you can fit nuclear waste like the Swiss do. All their nuclear waste is in one room in Switzerland, as opposed to all the waste that's put into the air, the carbon dioxide, from these renewable solutions. And beware of possible trade-offs before you buy. We found, we did some testing at our center with the help of the Canadian government. We did this hybrid system where it's solar panels, wind power, and we have a container of lead acid batteries, and we have one diesel generator to generate power to charge the batteries at night, and then we have the sun and the wind. So you see there's this green container where the batteries are, and what do you think those little pipes going into that battery container are? That's the air conditioning unit. Because when they're charging and discharging, the batteries get hot. Maybe lead acid battery is not the best solution, but that's the downside. So the wind turbine at its peak power was producing 6.5 kilowatts of power, but the air conditioner required 6.2. So, you really have to plan this. You have to think out what you want to do, what your goal is, and how you're going to get there. What is the plan? That I think it's not good, to do what I almost did. I'm going to go get an electric car. I'm going to get solar panels. And well, am I really going to help the problem, or am I going to make it worse? So that I want to be sure of. And that's why I need to think it out and make a good plan. And thank you for your attention. And we can go with questions, and I'll return the floor to you.
Thank you, Vytautas. As usual, very challenging and in a way mind-blowing information that you provide. Totally, untraditional point of view, which is based on actual analysis and actual observations, and not simply on the so-called, pink glasses view of the world where everything is nice and then it's getting better. So in fact, okay, we see the kind of the negative impacts of producing the sources of green energy, solar, wind, etc. So obviously, as you very correctly pointed out, there are big trade-offs. Things are improving, but way slower than we would like to. And the consumption, as you very correctly put out, is definitely not slowing down. It's actually increasing. So that is, a fact. We have to live with. We can declare a lot of things that we will reduce consumption, we will reduce greenhouse gases, etc. But life has to go on. Nobody will switch off the economy or the life. Mm-hmm. So what could be the solution? In your point of view, what could be the source, of energy that could, let's say, really be green?
Well, I hate to say this, and I watched the HBO series Chernobyl twice. And I visited the Ignalina nuclear power plant, which by the way, Ignalina, there was nothing wrong with Ignalina. It was had a very good safety record. It was one of the second largest RBMK nuclear power plants in the world. It was in its midlife. It still had many of good years left in it, but it was a requirement for joining the European Union was we had to shut down this Chernobyl-looking, which it wasn't. It was the later generation. But having said that, I really think if we're not going to change the lifestyle, so something's got to give someplace. You're not going to build a wind farm. You're not going to build a solar farm. You know what a solar farm means? It means you have to level land. You have to prepare a farmland, level it, cut down all the forests. Who cares about all the animals? In the United States state of Arizona, they did one of these. They bulldozed all their turtles. They're in the desert. These special turtles. So that has a cost. And if you look at,
of course, you can use the panels in cities. You can build them on rooftops.
Well, is your roof strong enough? In Vilnius we have čerpes, these clay. They're heavy roofs. Now you want to put on another ton on your roof, and then the snow is on there, and then are you going to hire somebody to go on your roof in the wintertime when it snows? Because the solar panel, you have to clean it.
I did it on both of my houses, actually. I put them on. So far the whole, so far.
And I don't know if you had any problems on hot days, because they can get too hot, because and they're only I think like 14 to 20% efficient. A lot of the sun, they reflect back the sun's heat.
It's up to 20% now. The newest model is up to 20%. Yes.
Okay, so again, that's the trade-off even with the solar panels, and then all the waste that is done, the waste products and things that I talked about, to the environment, where nuclear is well, it's been around for 60 years. We have had some accidents, but generally it's a very good safety record. You can make even more safety, make them more safe. There's also, you might ask one of my colleagues, he did a report on micro nuclear reactors, which are, not these big, giant Chernobyl things, but much smaller, that could provide power for a capital city, and that's just fine.
Container-sized reactors, essentially.
Yeah. So again, the amount of uranium you need is it fits inside the fist of my hand. And you can produce power for hundreds of years just on that uranium block, as opposed to spreading out all over your country these solar panels and wind power veins and the cement and everything else, ruining your landscape. You can have this, and then the waste. Yes, there is nuclear waste, but I saw a lecture yesterday about Switzerland. All their nuclear power, they use a lot of nuclear power in Switzerland. All their waste fits in one warehouse in Switzerland in these big containers. You have to look after them, watch them, but it's in one place. It's not spread out all over the country. And someday you could send that waste, put it on the moon or something, if you're worried about having it. But it's a trade-off. It's a manageable situation. If whatever you're doing with the renewables is just adding more carbon dioxide, and I haven't talked about natural gas, methane. Methane is a much bigger product of global warming gas than carbon dioxide is. If you want to use natural gas pipelines, they leak. Siberia, the permafrost is melting. There's a lot of methane in the Siberian permafrost. If that goes, watch out, if that melts. So the plus minus is the nuclear might be the way to go. But unfortunately, it has become very expensive. All these, the fear of Chernobyl, the nuclear, lots of regulations, lots of licenses, lots of certifications. Maybe we can find a way to kind of, make it more rational. Maybe bring the cost down, and then like Lithuania in the 1990, when Gorbachev put the economic blockade on Lithuania in the summer of 90, we had electricity, because Ignalina was running, and we were self-sufficient, and now we're going to join the Nord Pole grid, European grid, and we're going to be paying for the electricity that we buy from them, because we're not producing that much on our own.
There are, of course, new developments in joining the whole European electricity market over the century. wind generated, I don't know, in Spain, for example, could be transferred to the same Lithuania or Estonia, and vice versa. Wind generated in north of Sweden can be transferred to, I don't know, south of Italy. So that is the kind of development where actually you need so-called mass scale or the economy of scale in green energy as well. Because if you have so little of it, it really doesn't balance itself out.
Yeah.
But if you have a rather diversified geography of solar, of wind. So essentially and you have the so-called the break-even point of capacity. So it actually balances itself off over time, but you need to have the critical mass. So what we now lack is actually the critical mass, which is obvious. And we are still essentially 2.5 legs in the old energy production, and then maybe 1/2 leg, into the new one, and move by words rather than by deeds. So in fact, that also is a fact which has to be taken into account. And another aspect is obviously that nuclear is definitely cleaner than gas, for example, which for some very strange reason is attributed to clean energy, which is definitely not. But the thing is that nuclear, it's all about the architecture of electricity systems and electricity kind of grids. So that obviously nuclear is the classical representative of the classical grid structure, where you have one big generator and then a lot of small consumers, and then the system balances it. Now we are seeing more and more smart grids where actually the production and consumption is actually balanced locally, at site. So and kind of small producers, small consumers are enabled to, in fact, produce their own energy, for their own consumption needs. So that is also the new trend, which probably will balance out, at least partially, all these negative elements and effects that you have mentioned. But of course, you cannot say that all these kind of challenges and negative effects that you have mentioned do not exist. Definitely they do.
Yeah. Well, I provided a cybersecurity assessment of applying smart grid solutions to French military camps this past summer. And, a lot of militaries are looking at this smart grid, become independent of the grid. And especially when they go to these harmful, dangerous areas, Afghanistan, and, they want to have their own energy sources at the base and not have to send a truck with diesel fuel through a harmful, dangerous environment. So they're looking at it. But again, there's the downside is you have a lot of complexity added to the system. When you're a smart grid person, using smart grid, you have energy management system, you have battery management system, all these systems, it's all technology. And I'm afraid I'm going to jump into my cybersecurity pretty soon. But, and also it's advantageous to connect your smart grid to somebody else's grid. You share power, and you could, share with the national grid, sell the power, or when the sun goes down or it's not so cloudy, you can get from the power grids, national grid. But there's a technical caveat. You can do that, but you have to have a lot of these black boxes between the smart grid and the national grid, because when the sun goes down or the wind goes down, you've got to disconnect, because that's going to send a pulse of energy. It could damage equipment. So as you can do that. It's engineering. It's solvable, but again, it's adds to the complexity. And you're going to have to train people even more on how to manage that kind of thing.
It is becoming more and more complex, obviously. But
nothing is easy.
No, life is never
easy. No free lunch.
Unfortunately, there is the saying in Lithuanian language that the only place where you can get free cheese is in the mousetrap. So that's the saying, which unfortunately corresponds to the truth in many instances.
Yeah.
But I mean, turning over to the, let's say, maybe more political or strategic kind of insight. So essentially, you mentioned a lot of challenges, obstacles, etc. But what are the main obstacles, for addressing the negative impacts of all these, factors affecting the climate change?
Well, it's I think lack of planning, lack of looking at the questions that I've raised. How much is it really going to cost? What is the, how much of a benefit is that going to be? If you look at electric cars, for example, okay, you'll get the electric car, but you compare the electric car with the gasoline car, the break-even point where the savings of the electric car, out of all the carbon, the manufacturing, only comes up at 90,000 kilometers. After you drive your electric car for about 90,000 kilometers, then you could say it's better than the gas car. The gas car was actually more energy saving than the electric car, even though you're driving it, but the first 90,000 miles, it's a negative. So what that says to us is we have to find a better way to make the batteries. Tesla, their cars are made from aluminum, which is much more energy requirements and coal and everything else than steel is. So you need to look back at all that. And also, are you going to have enough charging stations? If you all go to these electric cars, where are you going to get the electricity from? You might have to build a coal plant to supply the power stations, and let alone setting them up on the street, maybe more cement to make the preparation of the area and drill into the ground and electric lines and everything else, the charging stations. So I think it's planning, weighing the pluses and minuses, and what is the technology able to do now? Right now, it's probably more cost efficient to get a hybrid car rather than a fully electric battery car because of this break-even point after 90,000 kilometers. Because with the hybrid car, for a while, if you don't step on the gas too much, the battery is, the electric motor is going along until you get past 50 kilometers an hour. So there's some savings there. And the battery is smaller in the hybrid car than it is in a full electric car. So this might be a temporary solution before you give the engineers a chance. How do we make better batteries that are not so cost intensive, resource intensive? We can recycle them or something. This has to be done. You have to plan it out, think it out, not just jump and say, oh, I want to buy a solar panel. I'm going to set it up. I'm going to start saving electricity and I'm going to help the climate change. It might be that it's going to get hotter outside than cooler.
So, well, actually, that comes to the question. I mean, so what is your kind of opinion? Why, we are still, in fact, getting hotter in the atmosphere, despite all the investments into green energy and all these, solar and wind capacities. So is this solely the reason of production, energy cost, or is there?
Well, it's a dilemma. We're trying to solve a problem that came from industrialization with more industrialization. It's a vicious circle. We put all this carbon into the atmosphere, so now we're going to try to save with renewables, but the manufacturer of those materials is going to put even more carbon in the atmosphere. You might close the coal plant down, but you're going to build probably 2 more natural gas. You're going to be putting more carbon in the atmosphere. So that is not the solution. The solution, part of it is a lifestyle change. Part of it is a government policy. I don't know about you or me, but I think you and I, we both drive our cars to work. Although we see the trolleys and the buses outside, but you don't want to go there on a rainy day, when people are coughing and sneezing and wait outside in the rain because, they don't come fast enough. There's a policy issue there. Maybe if you can make these alternatives, have a big parking lot outside of Vilnius and have a bus the people into work and then bring them back. They do that in Washington, D.C., by the way. People leave their house and they drive to the supermarket and they park their car at the supermarket, and then the bus is waiting for them, takes them into Washington, D.C., and they have a special lane buses that they can get through the traffic.
There were attempts about that in Vilnius as well, and other cities. I mean, so
you know, but
it's years ago. I don't know where it finished and what the actual result was. I haven't checked it. There were some attempts to do that.
It's like John Lennon said. I believe he said, "Think locally. Think what you could do nearby. You know, get your plastic, put it in the yellow igloo." And think globally, you know, get your political leadership, you know, maybe spend a little bit more money on transportation, make it more pleasurable, more attractive, and also do something about the lifestyle changes. You know, do we need to buy a new washer machine every other year? Maybe we can fix it. Do we need to get a new phone every year because the latest model has 15 more megapixels than the one that was before? You know, and all the materials, you know, we got to start rethinking our consumption habits. If we can reduce our consumption, then we can reduce the energy. And then maybe we can get by with what we have as far as power stations and not have to make more, not have to cut more forests to make the charcoal, to make the solar panels, and to make room for the solar farms, you know, cut all the flat lands. You know, this is a real conundrum, and you know, I don't have the answer, you know, but I can see where it could be moving, where it could be promising. That's all I can say. We're all in this together, you know. We're all in this together.
Unfortunately, we are. Unfortunately, we all are indeed. But I mean, coming to an end of our very interesting discussion, what would be your kind of three wishes, you know, to address the topics you just you know have raised? What would be the three wishes, you know, you would wish for? I don't know, world government, if such would exist, or local governments, or you know, economy, decision makers in economy, actually, because governments oftentimes not actually make decisions the world economy does. You know, so what could be the, you know, three things?
Well, in Lithuania, I attended a lot of seminars. There's the Energy Agency in Lithuania and Kaunas Technology University put on some good seminars. But the first thing I would do is we really need to have a new look at nuclear power. You know, what are the, you know, have things changed over the last few years? You know, maybe we can take another look at nuclear power. Maybe not build one like Ignalina, but maybe some of these micro reactors that show some promise. A little bit more manageable, smaller. You know, Lithuania is not a big country. You know, Ignalina produced much more power than Lithuania needed. It is something smaller. So you know, that is another thing. That, I think, is the easy thing, to have a meeting and to take another look at nuclear power, and maybe get the government to, you know, start thinking seriously about maybe we need to rebuild one of these smaller nuclear power plants to take care of Lithuania's energy needs and contribute to its responsibility for lowering carbon. And then everything else is hard after that. Lifestyle changes. You know, people have to restrain themselves. I have no idea how to do that. Don't buy so much. Don't buy so many washer machines. Make it easier to repair the washer machine or the dryer. Make it easier to repair the car rather than having to buy a new one. You know, that, you know, and so I think that's like the second and third lumped together. They're hard.
They're very hard. I mean, in fact, you know, my grandmother, she had a sewing machine, you know, that was made of hard metal, steel probably, or some kind of some brass, I don't know, but it was made like probably 100 years ago, and it's still functioning the same, you know, as good as it was functioning 100 years ago. You know, in fact, it does the function. So try to do that with a new sewing machine. It will be broken, I don't know, in a year probably, after more use.
This old style of living reminds me of a kind of like a funny story, but it's true apparently. If you would buy a horse and use the horse to take you from your work, I don't know how far away you live, but let's say to go from one side of Vilnius to the other with a horse, and then you use a car to go from one side of Vilnius to the other. Basically, the horse and the car produce the same amount of carbon dioxide, the same amount. But the only thing is, the car, gets carbon dioxide and it produces carbon dioxide, whereas the horse breathes in, it takes in oxygen and it gives out carbon dioxide. It eats plants that produce oxygen. So it's part of a cycle. It's part of a renewable cycle, whereas the car is just a one-way carbon. Whereas, the horse, that's an extreme funny solution. Everybody should go back to horses. Well, no, I owned a horse and I know it's hard to keep a horse. So, we want the cars and it's nice to go driving, but now we have to do it somehow smartly. The planning, if we set ourselves a goal, we want to reduce coal and gas consumption, but then we also have to reduce electricity consumption too. That's the hard part. We can do so much by buying the light bulbs, which cost like over €1 to get one of these energy saving light bulbs, and they break sometimes. But again, make it easier to repair these big, expensive, carbon intensive manufacturing items like washing machines and dryers and cars. Make them last longer. More recyclable materials, that ends up fewer carbon in the atmosphere, and just thinking of these ideas. And I think that's a lot of job opportunity for new companies, startups to come up with these things.
Last week I was in Sweden, in Stockholm actually, and the municipalities in Sweden, for example, Göteborg, have made calculations that essentially, if the traffic, the cars, the autobuses, etc., would be fully kind of turned over to AI, to kind of smart transportation, driverless transportation, we would essentially need 3 to 4 times less of vehicles in the streets. As a result of which we could, save huge amount of territories within the cities for parking, for underground parking, or streets actually, so and everything. So we could actually save a lot on that and make the function of transportation getting from A to B as efficient as it is now, or maybe even more efficient.
That's a good idea. That's good. That should be looked at. We should look at it. Oh, yeah. So
with that kind of positive note of future development, I'm sure that hopefully we will meet in some time, and we will have a discussion on how the new changes in technology and solutions have actually improved the overall situation, rather than voice concerns as we have today.
I look forward to that very much.
Me too.
To talk about one of these solutions that really works. I would very much look forward to that. I share that with you, Robert.
Absolutely, absolutely. So thank you very much, dear Vytautas. And in fact, once again, dear viewers, thanks for being with us. Please subscribe to our YouTube channel. I was your host, Robert Juodka, and let's meet up in our next editions and see you all around. Thank you. Bye-bye.
Bye-bye.